Hello everyone, my name is Andrew Santos. This is my persuasive and speech video, my final assignment. I am talking about engineering the unimaginable, how generative design is redefining mechanical engineering. Advanced mechanical engineering / technical communications. Look at the world around you. Every car you drive, every plane you fly in, and every machine you use was bound by the limits of human imagination and the strict constraints of traditional manufacturing. For decades, we as engineers drew lines, extruded shapes, and manually shaved off weights. But we are standing on the brink of a massive paradigm shift. Today, I want to persuade you that the future of mechanical engineering does not lie in manually drawing parts step by step, but in partnering with artificial intelligence through generative design and topology optimization to create structures that human minds couldn't conceive. Next slide. The core problem: material waste and efficiency bottlenecks. Traditional manufacturing forces blocky, heavy designs to accommodate milling and casting. Excess weight translates directly to energy inefficiency in automotive and aerospace applications. Engineers spend up to 70% of their time iterating minor design adjustments to satisfy stress requirements. The traditional engineering workflow is flawed. When we design a component, whether it's suspension control arm for a vehicle or a structural bracket, we often over-engineer it. We add mass to ensure safety because of our standard CAD tools only analyze what we draw. This results in heavy components, massive material waste during milling, and vehicles that consume more energy than necessary. We need a system that reserves this workflow, one where we define the constraints and the software solves for the absolute perfect geometry. Generative design and topology optimization. Topology optimization is a mathematical approach that optimizes material layout within a given design space. Generative design is an innovative design exploration process, AI, to generate multiple CAD ready solutions based on performance parameters. Key parameters are material types, manufacturing methods, 3D printing, CNC versus CNC, budget, and load constraints. This brings us to our solution: generative design and topology optimization. Instead of drawing an extrusion or revolve manually and guessing where the stress concentration lies, we tell the computer that part connects, what force it must withstand, and what material are we using. Then the AI runs hundreds of stress simulations simultaneously, growing material only where stress lines actually travel. The result: organic bone-line structures that are likely incredible, but structurally light, superior to anything a human could draw from scratch. Academic verification and the evidence. The core research: generative design in mechanical engineering, a review of current status, challenges, and future trends. Authors is J. McKnight's. Key findings for this slide is mass reductions up to 40% across mechanical components while maintaining identical structure safety factors. To prove this isn't just science fiction, let's look at the academic data. In a seminal review paper published in the Journal of Engineering Design titled General Design in Mechanical Engineering, a review of current status, challenges, and future trends, author J. McKnight and his research team analyzed the real-world deployment of these algorithms. They documented the across automotive and aerospace applications. Generative design consistently yielded mass reductions between 40 and 70% compared to traditional CAD modeling, all while maintaining the exact same structural safety factors. Establish credibility, which is the expert quote. The role of the engineer is shifting from drafting geometry to defining problems. Generative design allows us to explore vast designs that human intuition simply cannot reach. So, basically what we can't think of. By Dr. Helen S. Alawi, computational mechanic specialist. To build on McKnight's research, consider the words of Dr. Helen S. Alawi, a leading specialist in computational mechanics. She famously noted, the role of the engineer is shifting from the drafting geometry to defining problems. Generative design allows us to explore the vast design space that human intuition simply cannot reach. Think about that. We're no longer just draft persons, turning dials in softwares like PTC Creo or SolidWorks. We are problem definers. We dictate the physics, and the AI handles the geometric complexity. Real world impact, performance, and environmental benefits. Weight reduction, which is lighter vehicles mean lower fuel consumptions and faster acceleration. Part consolidation, turning a 20-piece welded assembly into a single generative printed component. Sustainability, drastic reduction in raw material consumption. What happens when you apply this? Okay. In the automotive industry, reducing a vehicle's weight by just 10% improves fuel economy or battery efficiency by up to 6 to 8%. Furthermore, generative design allows for part consolidation and mechanical assembly that used to require 20 separate pieces bolted and glued together can now be printed as a single structurally continuous component. This eliminates weak points, reduces manufacturing assembly lines, and slashes production cost. Conclusion and call to action. The future of engineering belongs to those who can adapt, embrace the synergy of AI and computational mechanics. Final thought, design smarter, not heavier. Which is, you can say, take your time in designing stuff. Make sure everything's right. Don't rush it, because if you rush it, you're not really thinking of everything you could think of. As future engineers, we afford to look backwards. Traditional technical drafting gives us our foundation, but optimization algorithms gives us our future. If we want to build a world that's more efficient, more sustainable, and structurally safer, we must embrace generative design as our ultimate teammate. Let us stop designing heavier and start designing smarter. Thank you. Bibliography. I'm gonna go back and show you guys all the slides, so it's included. I also wrote down everything here. Here, I'll show you right. Here's the first slide. Here's the second slide. Here's the third slide. Here's the fourth slide. Here's the fifth slide. Here's the sixth slide. Here's the seventh slide. Here's the eighth slide. And that's it. That's everything I had for this assignment. I hope you take this, learn from it as much as I did, since I am technically working on this assignment. I'm working on it as much as I can with one of my computer classes. I work on PTC Creo, and slowly, little by little, I'm learning as much as I can. And yeah, I mean, that's pretty much it. We have to, basically, a short summary, if you want, is work smarter, not harder. Go slowly, no, not quick. So we get stuff done efficiently, not quality over quantity. I feel like that's a saying. I could be wrong. And I appreciate you guys listening. Hope you guys have a wonderful day.